Greetings and welcome to our talk, Infrastructure as Code, Lessons Learned from Over 40 Customer Deployments. It's presented by Venkat Thiruvengadam. He's the CEO of DuploCloud and was in fact an early engineer at Microsoft Azure and the first developer and founding member in Azure's networking team. He wrote significant parts of the Azure compute and network controller stack and actually got to see Azure grow from 100-odd servers to millions of nodes in just a few years. My name's Tony Barbagallo. I'm the head of marketing and moderator for today's presentation. And as we go through the presentation, if you have any questions, just please type them in and I'll do my best to interject them throughout the talk. We will also save some time at the end for any additional questions or comments. So just before I turn it over to Venkat, one quick slide on who are we. So as I alluded to in Venkat's background, DuploCloud was founded by the early developers of Microsoft Azure. And our vision is really to make DevOps and infrastructure as code accessible to everyone, just as the cloud providers made compute, storage, and networking accessible to everyone. We have a number of customers, both larger customers as well as startups. You can see some of them listed here: CamiVision, Smarsh, Unifor, Lily.ai, and several others. And with that, I'm going to turn it over to Venkat to really go into the meat of the talk today.
Thanks, Tony. Thanks. Welcome, everyone. I think we're going to talk about infrastructure as code. I'm myself a developer by background. I think Tony gave my introduction. I think I had some understanding of infrastructure as a code some time back. A lot of it was true. And then to our surprise, I think a lot of it is also hidden. So I think we'll sort of like talk through that. I think I would say the majority of this conversation is probably not going to be about DuploCloud. It's basically just about Terraform and like what it does, what it doesn't, what people think, and what's hidden and so forth. So that's the agenda. So let's get started. Yeah, I mean, what is infrastructure as a code? I mean, it's like a well-known methodology of providing cloud infrastructure. You basically decide all the stuff that you want, from your VPCs to subnets and availability zones and virtual machines and RDS and everything. You basically put it in the form of a code. You sort of run it, and then it goes and gets provisioned. But yeah, of course, I mean, you have to provide all sorts of details to that. Like, for example, all the details that you would provide in the UI, you would want to provide it in the scripts. And a lot of these scripts are saved as templates. They can be repeated. You can code policies. So yeah, infrastructure, I mean, it's basically programming infrastructure as if a developer would build their product. So that's what infrastructure as code is. I mean, I'm assuming that for the sake of this conversation, you have some background in that. Yeah, so how do typically what we have seen people build infrastructure, right? And then they use IAC is that first, they would come and start by saying, okay, let's build what we call as the base infrastructure. This is your VPCs, subnets, availability zone, VPNs and stuff. Some people call it landing zones. Then after that is in place, you would go about building out what we call as the platform services. Like these are typically from the cloud providers. This includes your databases, your object store, S3, Dynamo, SQS, SNS, Elasticsearch, virtual machines, and so forth. So that's that. Then depending on what your application is, you would have various different application provisioning, which is like if you are containers, you do Kubernetes. If you're doing Lambda, you're doing serverless, you're doing Lambda, maybe SageMaker for AI engineers, you are big data, you're doing Spark and whatnot. Then you do a lot of application monitoring, logging, monitoring, metrics, alerts. And you can use tools like Datadog, Sumo Logic, and whatnot. And finally, CI/CD. Now, if you were to say where is infrastructure as code is primarily popular, is I would say more so on the left-hand side of this picture. All the base infrastructure configuration. And before I get there, across the board, you have to do a lot of security controls, tons and tons of them, depending on what compliance standard that you follow on. Like, for example, SOC 2, HIPAA are some of the more basic standards, including ISO, PCI, NIST. They are like much more higher configuration standards. So now coming to the tooling, like where is infrastructure as a code primarily used? It's more popular on the left side of the infrastructure. So you have your VPCs and stuff, app services, and a lot of the security controls, IAM, instance profile, KMS, all of that is done. App provisioning, I mean, Kubernetes has done sort of a great job at doing that. I would say that people use more the Helm charts and deployments. That's also code, but it's not particularly similar to Terraform. Terraform is like kind of an infrastructure as code. And then there's also CloudFormation. So I would basically say on the left-hand side and security, you use a lot of Terraform. App provisioning, there is Kubernetes, but if it's serverless and so on, you go back to Terraform or CloudFormation. And then application monitoring, I think we haven't seen a lot of IAC over there. And then CI/CD, people have their own proprietary languages, like GitHub has, most of them is YAML, and that depends on what they do. So that's how generally people go about building the infrastructure. So how do they really start? They would generally start by a high-level application specification, which is like, okay, an engineering team would say, I have a set of Docker containers. And that need to run on EKS or ECS. Maybe I have a set of Lambda functions that need to be exposed via an API gateway. Then I have a set of data stores, for example, Redis, PostgreSQL, Kinesis. And then I may be using Elasticsearch. Maybe I have a data science team that is using Spark clusters and so on. But at a high level, they would basically have the specification, and then they'll ask for a few more things. Okay, give me multiple environments. I want it to be secure. Make sure that it meets the compliance standards of my organization. Logging and monitoring should be there. Alerting should be there. CI/CD should be there. This is generally how like the requirements start. And this generally gets passed on to a DevOps engineer. DevOps engineers are the one who have the subject matter expertise, who will translate this high-level specification into hundreds of lower-level configurations. IAM role, instance profile, KMS key, PEM key, security groups, ACL, NACL. There are like tons and tons of them, depending on what the compliance standard is. If I were to take the same picture, if you have to like take just this diagram and make it PCI compliant, on Amazon, it will require maybe around 200 odd constructs that need to be provisioned. And in order to do that via infrastructure as code, you'll probably end up writing thousands and thousands of lines of code. So in that sense, I mean, you really need to know the granularity and require a tremendous amount of subject matter expertise, both in cloud providers, configurations, your security configurations, as in compliance standards. You need to know the compliance standards, and of course, you need to know programming so that you can go and do it. Yeah.
Venkat, aren't those controls already implemented via the cloud providers like AWS?
No, they actually don't implement the controls, Tony. It's a shared security model. They will give you the modules to implement those controls. I'll give an example. Let's say in the high-level diagram, they say, I want to deploy a Docker container and I need a SQL server. What you need to do, in order to create a SQL server, you need to encrypt it. In order to encrypt it, Amazon will give you what is known as a KMS key. It's an artifact or a config, but it's your responsibility to go and create the KMS key. And it's your responsibility to make sure that there are right set of IAM policies, which is another configuration, in order to latch it properly and latch it to the database. Similarly, another control, for example, PCI, sort of says that you have to store your passwords in Secrets Manager. So then Secrets Manager is another construct that Amazon gives, but it's your responsibility to take the password, put it in Secrets Manager, make sure that the place where the application is running, that EC2 instance, you have an IAM policy to latch it together. So if you see just in these few minutes, I talked about KMS, IAM policy, Secrets Manager, RDS. EC2 instance. So they'll give you the constructs, but it's your responsibility to interpret them and implement the end-to-end control.
So as a DevOps engineer or developer, I would have to write that infrastructure as code to implement everything you just said.
Yeah, you have to put everything together, basically, right? So it's pretty granular, right? I mean, you have to know quite a few details in order to get that, and that's why DevOps is a skill set by itself. Yeah. So yeah, I mean, if you see, right, I mean, these are like, there's a table which sort of shows a few high-level controls. PCI has like 80, high trust 80 plus, HIPAA 15 is 200 plus. SOC 2 is not there. SOC 2 is a very rudimentary one, but so is ISO. But these are like sort of the control set, and 70% of them actually have to be done provisioning time. And then about 30% of the one can be done post-provisioning, and you need to monitor it. So yeah, I mean, a lot of work, a lot of subject matter expertise, a lot of operational experience, and of course, good programming. If you were to really dig deeper into these compliance and security controls, like Tony, what you were asking, like the Amazon's PCI guide is actually 3,400 pages long. I know, of course, it covers all of Amazon services, but even if you pick the ones that are relevant to you, I mean, it's quite a bit. So that's why even for a small infrastructure, which is like 50 VMs, it takes people 6 months to get PCI compliant, and sometimes even a year. High trust, PCI, these are all, and HIPAA. It takes really a long time. But this is where the challenge is, because it takes a lot of expertise to convert high-level specification to lower level. And in that sense, I mean, I'll be frank, infrastructure as a code only helps you so much. I mean, it's still up to you to know all of it. It's like saying that you have to build a great product. A programming language like C or C++ can help you, but you still have to be a good programmer, and you need to know the design and everything. Right? So yeah, another thing is that, in fact, infrastructure as a code is still manageable when you write it the first time, right? Okay, this is my database, this is my EC2 instance, this is my containers. You can put that thing together. Where it gets really complicated is ongoing operations and making changes. And if you were to just look at purely from a programmer perspective, right? I mean, I guess all of you who are programmers would understand writing new code is always much easier than going and making changes to an existing code base, making sure things don't break, getting it through QA, code reviews and stuff like that. And the same situation is true for infrastructure as code as well. So that's like another aspect of it. And some of the things in the infrastructure, I mean, are not done typically via IAC, like compliance, reporting, like these kind of things are generally done outside. So that's that. Yeah, I mean, what is the general org structure that we have seen is that developers, generally speaking, don't have that kind of awareness of lower level infrastructure, unless some of them are tech leads who actually know. They send this information over to DevOps teams, and then the DevOps teams would basically convert it into lower level stuff. Part of the DevOps team is also a security team, and then they would provision it. And this is probably approximately how a life of a DevOps engineer looks like. Maybe like half of the time they would spend on security, and the rest of the half on the rest of the stuff. And this is maybe like for a HIPAA PCI kind of an infrastructure, 50 VMs, maybe you're talking about 10 to 20 microservices and so forth. So that's that. Then, okay, let's look at a little bit of a history, right? I mean, before infrastructure as code, like how people sort of like operated. Before infrastructure as code, actually, we had these concepts of what we used to call them as templates, and which were followed with cloud management platform. So what's a template? You might have heard of Chef templates, Puppet, and whatnot. So there, the concept was, okay, whatever the engineering teams needed, they would basically put it together in some simple scriptable format, and then they would just repeat it. So what would generally engineers ask? Okay, their set of VMs, maybe a database, maybe an Elasticsearch or stuff like that. So there wasn't a lot of volatility or variance. You would just take it and then repeat it again and again. What did cloud management platforms did? The cloud management platforms, by and large, were a way in which administrators could provision templates, make templates available, and engineering team and users could launch templates out of it in a self-service way. But anytime the topology changed, you had to go back and make changes to the templates. And this was okay till about like 2015, 2016, till Docker took off and microservices came into picture. Once they came in and the cloud providers also added these huge set of new platform services, S3, Dynamo, SQS, SNS, KNSS, SageMaker, EMR, and there are like so many in Azure and so forth. Templates completely broke down. There were like so many changes needed. It was just not a language which was appropriate to keep up with ongoing changes and everything. So once templatization approach broke down, the CMPs automatically sort of broke down as well, right? So they didn't work. So that's when infrastructure as code came in. So people said, you know what, we are looking at a system or an infrastructure which we have to keep changing as if we are changing the product. So why don't we take the same technique that we use to build products and make it apply it to infrastructure? And that's what led to infrastructure as code. So basically, so then Terraform is one of the languages, CloudFormation is another language, and I think now Ansible has also become very good and so forth. So that led to infrastructure as code. So the idea was that, just track everything in your repository. People can code review it. You can iterate over it. If something goes wrong, you know how you go back and revert your code. You go revert your code and then find out what's going on and whatnot. And of course, the repeatability was always there. You apply it in one environment and you take the same code, maybe change some variables and put it over into another code. So I think it brings in a great set of benefits to the system. All right. Now, this is the part that probably you have to really be using it in order to find out what's going on. So what did infrastructure as code do? Infrastructure as a code said, oh, you know what? Infrastructure is changing all the time. Why don't we just take a programming language and then make it make infrastructure be infrastructure as a code? But wait, in order to write code, you need developers, right? And then but then you also need to know operations, right? You need to know all the details of security, compliance, vulnerabilities, virus scanning, and this and that. So how many developers actually know all these details, effectively operations? And how many operators actually know how to code? No offense to either of the groups, but developer who knows operations and an operator who can actually write a code is a unicorn skill. And that, what we have seen, is a number one problem, effectively. And it's very hard for people to basically go and make changes. That's one. Second thing is that, here we're playing with sort of a words in the sense that depending on how you define declarative, I'm not so sure that Terraform is actually declarative. Yes, it's a declarative in the sense that you can go and create your VPCs and KMS keys and PEM keys and whatnot. But if I go and define declarative as a very high-level application specification, the original picture that I showed you, then Terraform doesn't operate at that level. Or it's not about Terraform. In general, IAC doesn't operate at that level. So if I am a user, I am looking for a platform which is a lot more declarative than where infrastructure as a code is. I want to basically say, give me a VM, give me a virtual, give me a SQL server, make sure that they connect with each other and do whatever you need to do underneath to make them PCI compliant, right? And whatever, of course, are in my purview, I'll take care of it, but the infrastructure should be done. So that's one. The third thing that we really looked at is that we'll talk about how it is much harder to maintain than writing it the first time. And then we'll also talk about, this was like the most interesting and an eye-opening thing, that infrastructure as code is actually not multi-user self-service. It kills multi-user self-service. So we'll talk a little bit more in detail. Right. So yeah, this is what we talked about. If you have to dig a little bit deeper, right? If you go to most organizations, IT and enterprises, IT teams don't write code. They are like different skill set. The and similarly, developers are not operators. The pay grades are different. The overall organization, the budgets, everything are different. So it really causes a lot of disruption, right? So I think this, I feel, is like is a big issue, and they're like thousands and thousands. Yeah, go ahead, Tony.
So are companies now putting developers into the IT administrations, IT staff, IT groups?
Yeah, I think they're all trying. I think still people are trying to figure out, does DevOps means developer doing ops, or does DevOps mean operators learning to be a developer?
And I guess if those developers are put in the IT teams, they still need to be familiar with the actual applications that they're working on.
Yeah, so I'll tell you what I've seen, Tony, is in the small and medium enterprise segment, like more startups and so on. I think the developers are picking up operations. So in that sense, I think that's what is happening. But in larger enterprises, I think they're trying to see if they can retrain operators to be a little bit of developers and learn infrastructure as code. But yeah, I mean, it's a challenge. I mean, you have to change a lot of things. You have to change the culture, you have to change the budgets and so forth. So, I mean, if somebody becomes a very good developer, maybe sometimes they just want to get out of operations and start doing development. So all those challenges are also there. So this is like a big problem to solve. Yeah, and I talked about, right? I mean, this is what I was talking about in detail. I mean, depending on how you define declarative. For me, this is declarative, right? I mean, I should be able to give this, and the system should be able to create whatever it needs to do. And then this is not fixed. It's not a template. I should be able to come up with whatever combination that I need. Today, you give this to a human being, and the human being comes down to the lower level specification. So that's that. And this thing about like improving the abstractions, this is not something like that has not happened. I think my opinion is that infrastructure as a code would evolve a lot, basically, right? So just let's look at the example of how general mainstream programming evolved, right? So you had assembly, and then people came up with C, and people were like, wow, this is so awesome. I don't have to write assembly statements. And then people came up with object-oriented languages like C++. It's like, wow, this is even better. This is even a better layer of abstractions like classes, polymorphism, inheritance. And then came managed languages, like, for example, Java. Now you don't even have to worry about memory management, right? I mean, C++ brought in smart pointers. Managed languages basically said, declare the variable and forget about it. We'll have a garbage collector. We'll have a JVM. It'll take care of it. Right. And then there were frameworks for REST, SOAP, async, and all that kind of stuff. And then, of course, there is the cloud services. When they came in, like even your message bus, notification system, search, service bus, all of those were automated. And then now people are talking about low code, no code. You just drag and drop, and then you have your application ready. In the UI world, that's already very common. With mobile, there is honeycode and whatnot. So you see that even mainstream programming has gone many levels, but infrastructure as a code has not like gone that far. Like, I mean, where you had Bash, PowerShell, you went to Chef, Puppet, and now with Terraform, maybe you have some modules and connectors and so on. So I think we have a long way to go in order to do that. So yeah, and this is like an example. I think I've sort of made this point well in detail about like what you really need is create me an infrastructure, this region, this seeder, and this many availability zone, and should automatically create it. Now, one could say is that, well, hey, infrastructure as code has modules or functions. That's what they do. Like, what more do you need? So let me give you my take on that. So what I mean by modules, let's say let me use an analogy. You're using, let's say if Terraform were like C language. In C language, if you want to do allocate and release memory, you would write functions, maybe something to allocate memory. You have functions to maybe release memory, and you would use it and whatnot. You have to be careful when to call it, when not to call it, and all that kind of stuff. When we move to Java, you don't even have to worry about memory management, basically, right? I mean, you declare the variable and move on. It's being done by the platform. There are no functions. So in this analogy, C is like Terraform. Modules is like functions, But what we really need is we need to move to Java, wherein I don't have to even deal with the lower level nuances of encrypting a database and creating an IAM policy when I have to connect a database with a EC2 instance. I should be able to say, connect this EC2 instance to this database. It should be able to figure it out. I should not have to go and hunt for a function or a module and pass it parameters and say, hey, this is the right module and this is how it should be done. That's what I mean by a higher layer of abstraction. So maintaining infrastructure is harder. So what do I mean? So if some of you are operators, in regular operations, how do people operate? Let's say there is a running service, there is an attack, right? Maybe there is an attack on the WAF, maybe you want to add a rule, or maybe there is something wrong with the security group, you want to go and open a port or close a port, something like that. What have traditionally operators been able to do? They get into the console, go to that specific security group, add a rule, save it, and come out of it. Or maybe make a small change to the WAF and come out of it. Now, with infrastructure as a code, you have a project which is a set of code base, which is doing your databases, it is doing EC2 instances, it is doing security group, maybe it's also doing WAF. How much ever you basically modularize it, it's definitely going to do 10 things. Give this to an operator and the operator is like, man, I need to go and change a security group. Now I have to basically go and understand what is the impact of this on the rest of the system. I have to do a plan. I have to do an apply. I don't know if I'm going to break something else. It's like an unnecessary headache for them. If you are really a tool operator. And that sort of like makes Terraform kind of a thing harder, because suddenly where people were used to making a very specific targeted change, now they are forced to look at and review so many other lines of code. And worse, if your state file is not in sync with what the system is, you want to open a security group port and suddenly Terraform tells you or CloudFormation tells you that there is a diff in a database configuration. At this point of time, what do operators do? They'll like, forget about this. Let me go to console. Let me basically go and make the change and let a real infrastructure as a code engineer come, import it, and then solve this problem. So we see that all the time. So that way, I think it becomes like sort of really difficult to scale unless you're really a ninja DevOps engineer who can really make these changes like that. And to that extent, people don't roll out products like this. I mean, how did we come to infrastructure as code? We said coding is what's used for products. Let's pick up coding. But products are not like this just-in-time changes. Nobody asked you to go and roll out a product change in a matter of minutes or even an hour. There's a process, there's a QA, there's a hotfix and all that kind of stuff. But you don't have that luxury in infrastructure as code, in infrastructure. So that's where I think that choice makes it very difficult, and there is a mismatch over there. Then, multi-user self-service. So what do we mean by this? So this is very interesting. Generally, how do operators work? One person is going and making changes in security groups. There's another guy who's dealing with database. Maybe someone else is making some changes with the vulnerability scanning or the VMs and stuff like that. They're used to operating on their own. But now with infrastructure as a code, you have combined all of them, put it into a script that only one person can run effectively. So everybody else is waiting, right? And then now once one person goes and makes a change, the other person may be ready with this change, but now suddenly they have to basically go and pull their configurations and make changes and so forth. So this was actually not intuitive to us, but we realized it. Now, the side effect of this is that, like, now if I were to bring in a little bit of Duplo in the mix, Duplo provides both interfaces. You can program Duplo using Terraform, using our provider, and you can program Duplo using using the UI. If I were to ask you a question, I wish this was live, I could have asked this question. We have an audience which is a set of engineers, developers, and we have an audience which is a set of DevOps engineers. Who do you think prefers Terraform or infrastructure as code, and who do you think prefers the UI? A very counterintuitive, however counterintuitive it may be, the answer is the developers actually prefer the UI and the DevOps engineer prefer the code effectively, because it's just the faster way of doing things in that particular context, basically, because the developers are already dealing with their code. They don't want to go and deal with something which is unknown. because the UI gives them like a just-in-time, very modular access. But this is something that we learn. Like wherever there is infrastructure as a code, it's a single user system. There are like 1 or 2 users who use it. Wherever we had to do self-service, where 50 users had to operate, we had to fall back on UI. We had like no other choice. Maybe someday some technology will solve this, but we'll find out. Yeah, I mean, like how now with that, maybe we can switch gears a little bit and then talk about like how we can make infrastructure as code better. I think one of the things that we need to do is that we have to make infrastructure as a code operate at a higher level of abstraction. And that's not through modules. I mean, the platform by itself has to be able to support it. It should be able to take a higher level application specification and have some sort of a rules-based engine, and it should be able to automatically generate what it needs to be done. And of course, it has to be made more accessible to developers and operators, and it has to be easier. It cannot be like this hard to do. Now, if we were to like dig a little bit deeper, you cannot get to an app-centric interface or a rules-based engine unless you have a very active, stateful component which is running behind the scenes in a centralized way. What do I mean by that? Today, infrastructure as a code is purely a compiler and a coding language that runs in people's laptops. So if there are like 5 people, there is no way those 5 people can simultaneously coordinate because there is no central system. So just like when we graduated from C to Java, they introduced the JVM. The JVM is the one who actually has the intelligence of garbage collection and everything and stuff like that. And the frameworks are implemented in that. Similar to that, you need a VM basically, right? So you need a stateful component that runs in the cloud account to which infrastructure as code can go through, and that can actually add intelligence. So effectively what you need is that rules-based engine. It can take app-centric information, automatically run the rules, make sure SOC 2, PCI, HIPAA, and all those things are taken care. And it's not like this has not been done before. If you see what did cloud really do, cloud, when they introduced infrastructure as a service, they basically took all these disparate storage, compute, network, OS, security, and then sort of like made it as a service. Like for example, what is a VPC? Like you give a name and a seeder and it creates a VPC. You don't have to deal with BGP, OSPF, VERFs, VLANs, and like all those tons of Cisco stuff, right? So it's being done. Similarly, Kubernetes, which is a more contemporary example, right? I mean, it has abstracted so many lower level details of application deployment and just exposed things like simple deployment steps. Well, Kubernetes is not simple, but still, I mean, it has abstracted a lot of things and provided you deployment set, service, DNS and stuff. And you don't have to go with the lower level details of CNAME, load balancing and all that. So it has done a good job and it's becoming more and more easier to use. And that's actually a very good example. So such an abstraction needs to happen across the board in the infrastructure, and especially compliance and security. That's like the number one pain point, right? And how that needs to be done. I mean, like I said, there needs to be a stateful, intelligent, smart backend for infrastructure as code.
So Venkat, even startups need to worry about compliance?
Yeah, I mean, if a startup is operating in a regulated industry and your clients are large enterprises, right? I mean, they're going to send you a big questionnaire and tell you to be compliant to those questions, right? And if you have to answer that, you have to deal with all this. So I think that's the problem.
And I guess SOC 2 it goes even beyond that, not necessarily even for regulated industries.
Yeah, I think the thing with SOC 2 and ISO is that I would basically say infrastructure has 2 parts, or overall an organization's compliance has 2 parts. One is around the processes and stuff like that. So I would say SOC 2, ISO are standards which are very heavily focused on processes. And then what these enterprises do is that they would give you a list of questions which deal with a lot of lower level details. basically. So they are typically picked up from PCI and whatnot. So almost everybody together with SOC 2 will get you so far, but then in order to answer all the questions, they need to have PCI grade controls. I mean, the enterprises don't say per se that they need PCI. They'll just ask for SOC 2, but they'll send a questionnaire which actually has PCI and NIST controls. So yeah, it's a real challenge for the startups. Yeah, but yeah, I mean, this is really the vision that we are outlining, right? I mean, start with a high-level specification, input the compliance standards that you need, and then the system should automatically be able to like auto-generate a lot of this lower-level configurations and stuff. Then, yeah, I mean, we talked about developer self-service, right? I mean, people should not need to know tons of lower-level details of the infrastructure in order to operate on it. And at the same time, they should not be allowed to violate compliance and screw up security and so forth. So some amount of code generation and all that kind of stuff. You should just expose like a little higher level constructs. And end of the day, I mean, I understand if you expose a higher level constructs, you always lose a little bit of a control and flexibility, but then you can directly go to the cloud provider and make those modifications. So, I mean, it's like a 90-10 principle. I mean, like you can do 90% of the things with a higher level abstraction today, and maybe 10% you can go and to the lower level Terraform or ISC and then cloud providers and do those stuff. Yeah, I mean, yeah, that's what we've been saying. Like we sort of see if you can add some sort of an intelligence, rules-based engine or an orchestration on top of the cloud provider. And that orchestration can still be driven by infrastructure as code. We're not saying that you shouldn't have infrastructure as code. Absolutely, you can have infrastructure as code, but it can be a lot higher level. You don't have to write a web app using C language. I mean, if you want to write a web app, you can actually use like Node.js or something. So we need a much better language with a stateful backend, which basically does this in order to do this. And I'm pretty sure this is going to be a reality. I mean, it cannot stay the way it did. And we showed you how programming languages evolved. I'm pretty sure infrastructure as code will evolve also in that same way. And to some extent, I mean, we at DuploCloud, that's what we do. But then there's not so much about DuploCloud.
Although it is a good lead into the next slide.
Yeah. So that's what I was trying to basically say, right? I mean, you need to, by the way, today, right, there is that smart middle layer today. It's not like that smart middle layer doesn't exist. It's just that it's a human being. And then it's very difficult to find those human beings. So the idea is to basically automate a lot of things. I mean, that's what we did in DuploCloud. We sort of built this smart, intelligent rules-based engine, which takes 3 inputs, like we've been saying: high-level application specification, compliance standards, and the cloud platform. And it's automatically create the lower-level infrastructure and operate it. I mean, yeah, you have to write 10 times less code. Obviously, things will be faster, and it will be the fastest way to get to security and compliance. I mean, we can create get to a PCI compliant infrastructure in about like a week or 2. So yeah, I mean, overall, the industry is moving to low code, no code. I mean, it's a big buzz. It'll soon catch up with infrastructure and then go from there. And then, yeah, I mean, this is DuploCloud. This is DuploCloud. And then, yeah, this is the overall things that it actually does, from app deployment to diagnostics to platform services to CI/CD. We just wanted to give you a gist of this in this webinar. And then, yeah, it's like think of it like a managed DevSecOps platform. Yeah, we can open it for questions.
Yeah, so one of the questions here is going back to just getting a better understanding of security controls. And again, it as you said before, it's still the responsibility of the developer
Yes.
to implement the security controls. Although it looks like with the DuploCloud platform, it says on the diagram that they're built in. So the question was, can you clarify that?
Yeah, so what it basically means is that I'll maybe clarify with an example, right? Let's say you are operating in a PCI compliant infrastructure. You want to create an RDS database. So what the system will do is that it'll ask you for the username and password for the database. Internally, it will make sure that the encryption keys are generated, the RDS is encrypted, a secrets manager, the username passwords are encrypted into secrets manager. There's an IAM policy that is created to accept to make sure that the connectivity is fine and all that. So you operate at a very high level details, and behind the scenes, all the configurations are generated as per the compliance standard. And then you can run some sort of a compliance checker tool like AWS Security Hub and something, and then you get a good score. So it becomes like implicit, so you don't have to worry about it.
So I guess that is like your analogy of C versus Java, whereby in the case of DuploCloud, it's implementing those memory allocation and deallocation, so I don't have to worry about that.
Yeah, declare the variable and forget about it. Right, when it goes out of scope, the memory will be released. Right, in a very similar way, declare your database. We'll make sure that it's compliant.
And then another one here: how do you support audits?
Yeah, I think there are a few ways to support audit. Primarily, it's the auditing dashboard that comes out of the box in the platform. And that is actually built by relying on third-party tools, because it would be funny if DuploCloud audits itself. So after the system has been set up or it's operating, DuploCloud orchestrates a set of third-party reporting tools and a SIM solution, which would go and measure the compliance configurations and give you a score. That's one. And the second way is that there are a lot of tools like Vantat, Tugboat, Drata, and so on. So if you have any one of them and you point it to your cloud infrastructure, which is being managed by DuploCloud, you'll find all those controls are green. So yeah, auditing becomes really easy. You have the reporting, any tool can connect to it, and they'll find it green.
And then last one I have here, you say no code and low code. How is this platform both?
Yeah, so if you are using the UI, the audience which is using the UI, they're not writing any code. So for them, it's no code. They're just dealing with that. And for the audience which is using the Terraform provider or the SDK, for them, it is low code, because they have to now write 10 times lesser code, or even sometimes 100 times lesser code.
So and then it says if I'm using the UI, is there a way to see the code that's generated, or what if I want to migrate that somewhere else? How do I do that?
Yeah, I mean, I guess your question is that, let's say you're using DuploCloud and you want to get rid of DuploCloud, right? I mean, are you stuck with it? So the answer is no, you're not stuck with it. You have created an infrastructure and you're operating using DuploCloud. You want to not have it anymore. You click a button in DuploCloud. DuploCloud will go and generate a lower level native vanilla Terraform for you. And then you can take it and then you can delete the DuploCloud VM. And from that point onwards, you can use the vanilla Terraform from that you got exported from DuploCloud.
Okay. I'm not seeing any other questions. Thank you very much, Venkat. I hope this was informative to everyone, and both those that watch live and those that will be watching on demand in the future. So again, thank you all very much. Have a good rest of the day.
Bye.
Bye-bye.